Before it shines in a vault or powers modern technology, silver begins deep beneath the Earth's surface. Hidden in solid rock, it must pass through blasting, crushing, fire, and precision refining before it reaches our hands. This is the remarkable industrial journey of silver, from darkness to brilliance. Every silver journey begins long before mining equipment arrives. It starts with science, reading the language of the Earth. Geologists study rock formations, satellite imagery, and subtle magnetic signals to locate hidden mineral systems. The purpose is to identify ore bodies that contain economically recoverable silver. Silver is rarely found in pure form. It is most often associated with lead, zinc, copper, or gold deposits.
As shown, recovery rates are up 12% this quarter. Compliance is at 98 checks. The map shows the details.
Once a promising zone is identified, core drilling begins. Hollow drill bits extract cylindrical rock samples from deep underground. These cores reveal the structure, depth, and metal concentration of the deposit. In laboratories, samples are crushed, pulverized, and chemically analyzed to measure silver content precisely. Even a few ounces of silver per ton of ore—
Ready to dump! Open the chute! Chute opening! Stand clear!
can determine whether a project moves forward. Discovery alone is not enough. The project must prove viable, technically, economically, and environmentally. Engineers calculate production costs, infrastructure needs, and long-term profitability. Environmental teams assess impacts on water, soil, wildlife, and surrounding communities. Modern mining projects often spend years in review before approval is granted. With approvals secured, construction begins. Access to the ore must be created safely and efficiently. If the deposit lies near the surface, an open-pit mine is excavated in stepped benches. Solid rock must be broken before it can be processed. Precision drilling rigs bore holes into the ore body. Controlled explosives are placed and detonated to fragment the rock. The purpose is to create manageable pieces for loading and transport. Blasts are carefully timed to milliseconds to control vibration and maximize efficiency. After blasting, heavy excavators load ore into massive haul trucks. The goal is to move the material from the mine to the processing facility safely and continuously. Some haul trucks carry more than 300 tons per load. In underground operations, conveyor systems or rail carts transport ore to the surface. At the processing plant, the ore undergoes size reduction. Large crushers break rocks into smaller fragments. Grinding mills then reduce the material into a fine slurry mixed with water.
Careful with that one, it's heavy! Clear, coming through.
The finely ground slurry enters flotation tanks. Air bubbles and specialized reagents are introduced. Silver-bearing minerals attach to the bubbles and rise to form a froth layer, separating from waste. Inside high-temperature furnaces, it is melted to separate metal from remaining impurities. Silver is often recovered from molten lead bullion during this stage. Furnace temperatures can exceed 1,000 degrees Celsius, reshaping solid concentrate into liquid metal. Smelted metal still contains trace impurities. Refining brings silver to high purity standards. In electrorefining, an electric current dissolves impure silver and redeposits it as nearly pure crystals. Chemical refining methods may further remove remaining contaminants. The final product typically reaches 99.9% purity or higher.
Careful with that one, it's heavy! Clear, coming through.
Let's check the silver charts. Volatility is up, but the trend is stable.
If you found this journey insightful, support the channel by liking the video and sharing it with others who appreciate real industrial stories. Subscribe for more in-depth documentaries exploring the science and engineering behind the world around us.